3D printing inside live human cells is now possible. At first glance, it seems an unfeasible idea to create three-dimensional objects inside a still living cell. Yet great strides have been made. Human cells are microscopic, extremely delicate, and already full of elements essential for survival. Suffice it to say that in a space of just 20 micrometers, organelles, proteins, and biochemical processes coexist in continuous movement. But it is precisely in this crowded environment that a group of researchers has managed to build solid structures without immediately compromising cellular life. For years, inserting something solid inside a cell was almost impossible because larger objects remain isolated in small vesicles and don't communicate with the cytoplasm. Traditional techniques, such as microinjection, work well with liquids and molecules, but do not allow for the creation of free three-dimensional shapes inside the cell. The first success of this process comes thanks to an extremely refined use of lasers, based on a technique called two-photon polymerization. In practice, tiny quantities of a non-toxic photosensitive material are introduced into HeLa cells. Then, an ultra-fast laser comes into action. Guided through a microscope, the laser solidifies the material only at the exact point hit by the beam, while everything around it remains intact. Using this technique, researchers are able to build complex objects, layer by layer, directly into the cytoplasm of the living cell. To verify its versatility, structures of different shapes were created, including microscopic lattices, hollow spheres, and surprisingly detailed decorative figures. Microscope images show these constructions are truly inside the cell, to the point that in some cases the nucleus deforms slightly to accommodate them. The effect on cell survival exists, but it's not catastrophic. After 24 hours, about 55% of the cells survive the treatment. Cells that resist continue to behave normally. They maintain their structure, divide, and even transmit the microstructures to daughter cells. Currently, the process requires one cell at a time. Voluminous objects can slow division, so large-scale application isn't feasible just yet. Think of internal sensors or targeted drug delivery systems. There is still a long way to go, but the journey of internal cell engineering has begun.